This is a walkthrough of Problem 1 on Exam 2 of Module 8 in the book Problem Solving Guide for Electromagnetism and Optics. Problem 1. A long wire with a semicircular loop of diameter 10 centimeters carries a current of 400 milliamps in the clockwise direction around the loop. So it's upward, around the loop, and then off to the right. What is the magnetic field at the center of the loop? Right here. Let's address that first. And to do that, we'll divide the wire into three sections: a vertical piece, half an arc, and a horizontal piece. And we're going to calculate the contribution from each. This part of the wire is a distance, perpendicular distance r away, the radius of the arc, which is 5 centimeters. It's half infinite. One angle is 90 degrees, the other angle is 0. The magnetic field contribution from this wire, the 1 is for the half infinite, the current is 400 milliamps, the perpendicular distance is 5 centimeters. Converting them all to SI units, we get that the field contribution from the vertical wire at this point, the center of the arc, is 0.8 microtesla, and it is into the page. Using the right-hand rule, stick a thumb along the current, which is upward. On the right side of the wire, it's into the page. Now the arc. The contribution from the semicircle is mu naught I over 4 pi r theta. The angle of the arc is pi radians. The current is 400 milliamps. The radius of the arc, 5 centimeters. Converting to SI units, we get that the field is 2.51 microtesla from the half arc, and it is also into the page using the right-hand rule. Now let's look at this horizontal part of the wire. It does not contribute because it has no perpendicular distance. The field from this horizontal wire is around the wire, loops around the wire. Here, there's no perpendicular distance. This does not contribute. So there are the three pieces, the three fields: 0.8 microtesla into the page, 2.51 microtesla into the page, 0 microtesla. The total is 3.31 microtesla into the page. That's part A. Part B, we have this wire here, long in both directions. Current is to the right. We're going to move it up slowly until the field goes to 0. Right here. First thing we have to do is figure out where it is. We know that this field is 3.31 microtesla into the page. In order for this to cancel it out, it must produce 3.31 microtesla out of the page. The current is to the right. Using the right-hand rule, the field above the wire is out of the page. The field below the wire is into the page. So we want the wire to be some distance below, because we need this second wire to produce a field that's out of the page to cancel the field from this wire, which is into the page. So there's some distance below the center of the arc. We have to calculate that distance. How far away does this wire have to be from that point so it produces a magnetic field of 3.31 microtesla? It's double infinite. The current in this wire is half an amp, 500 milliamps, and the A is the unknown, and we know the field. The 2 is there because it's double infinite. We can solve for A by multiplying both sides by A and dividing both sides by 3.31 microtesla. I put it in SI units, amps, teslas. And the distance is, the result is 0.03 meters, which is 3 centimeters. So the answer is 3 centimeters below the center of the arc, about right here. That's problem 1.